Okay, here we go. So today we're going to do surface area of pyramids and cones. Okay, I'm going to start with the pyramid. And if you look in the past when we did surface area, we did where the surface area was pH plus 2b. But if you look at this now, we don't have two bases. We just have one. Okay? I just have a single base. All right? So we're going to still find the area of the base, which is a square. Okay? And then we're going to go find the perimeter of this base. And then we have the other thing we find is the slant height. Now this is the one that's different. It's the one that's on the outside, not the actual height of the pyramid, which would be between my fingers. Okay, the slant height is the one on the outside, not the one on the inside. Okay, if you look at this cone, it kind of shows the red line down the middle. That is the actual height. Okay, this would be the slant height, which is the one that's actually on the outside. So we're going to have to, sometimes it'll be given to us, other times the height will be given, and we'll have to compute it. So it'll be the same for both, the way we'll find it. But again, we're going to find one base, area of the base, plus the perimeter times half of the slant height. Why is it a half? Because we have triangles. And actually there are 4 triangles on it. Okay? So if you look at the sheet we gave that we gave you, so we're going to look at this first example and just come up with reminding ourselves what each of the things mean. B, and I hope you're filling this in with me, is the area of the base, as always. P is the perimeter of the base. And L is our slant height, okay? Which if you look, it is the one that's on the outside, okay? This is the height of the cone, or the cylinder. Same thing over here. It's the height of the cone over here, and the slant height's on the outside. So both of them are very similar, okay? And our formula we're going to use is we know it's going to be the perimeter times the slant height, but we're going to take half of that because we have triangles. But then how many bases did we have? Just one. Okay? So that's what we're going to use on all of our pyramids is 1/2 PL plus B. Okay? So if you look at number 2, what we're given there is, well, first of all, we're going to go redraw the base every time. And if you look at the base here, and I really want you to redraw it with me, is if you look at our base, it is a square and each side is 8. Okay? And then from there, we're going to find the perimeter. Well, it's 8 plus 8 plus 8 plus 8, and that's 32. And the area of our base, well, it's just the product of 2 of the sides, is 8 times 8 is 64. Okay, now I got to look at, well, which is the slant height? Well, it's the one that's not the one on the inside is our height. That's not the one we're looking for. We're looking for the one on the outside, which is the slant height, which in this case is 12. Okay, so we're able to easily find all of those. Okay, now we're actually going to go compute the surface area. And each time, I really encourage you, I want you to write the formula each time. It's 1/2 PL plus B. We will put it in our foldable. So that's 1/2 of 32 times our slant height, which is 12, plus B, which was 64. And if I would go add all of those together, multiply it out and add it together, I would get 256, and that would be inches squared, because surface area, as we know, it's area, so it's a unit squared. Okay? All right, so now we're going to jump down to number 4. Okay, but in this one, I want you to look. The length that's given on the inside, which is 15, is not L. Remember, L is the one that's on the outside. Okay, so we're going to have to go compute that. But meanwhile, let's go ahead and redraw that base, which is this. So if it's 20 here, it's also going to be 20 over there. So it's all sides are 20 because our bases are going to be squares. Okay, so if we go find our perimeter, it's 20 plus 20 plus 20 plus 20, which is 80. And the area of our base is 20 times 20, which is 400. Okay, now that slant height, we need to go and actually compute it. So on all these, you're either being given the slant height or you're going to be given the height, and you got to go compute the slant height. Okay, so we're going to go redraw this triangle right here. Okay, and it is a right triangle. Okay, so this is 15, this is L, and I know you always say, oh, it's 20 down here. No, it's not. This height falls right in the middle, so if this whole thing is 20, it's going to be half of that, which is what? 10. Okay, when over here, it's just like the radius of the circle. Okay, it's half of it. So if you make that connection, that here is just the radius. Okay, so if we go set this up now, how do I find, if I'm given two sides on a triangle, how do I find the third? Well, it's going to be Pythagorean, and I'm going to do 15 squared plus 10 squared is L squared. If I multiply that out and add those together, I get 325, because this is 225 plus 100. To get L by itself, I'm going to take the square root. And if I take the square root of 325, okay, and I change to decimal, I get 18.03. Okay, so now I know L is 18.03, and I know all the information I need. So for a pyramid, it's going to be 1/2 of PL plus B. So let's go plug everything in. I get half of P, which was 80, times the slant height, which was 18.03, plus one of the bases, which is 400. And if I do 0.5 times 80 times 18.03 plus 400, I get 1121.20, and that would be, units weren't given on this one, so that's going to be our final answer. Okay. Okay, but it would be units squared, so if those were inches, be inches squared. Okay. All right. So just the key on these is, first of all, you got to redraw the base, because you get the perimeter and the base on both of those, perimeter and base on both of those. And then the other key is realizing is the length. If it's on the we're looking for the one that's on the outside. If it's given on the one on the outside, that is your slant height. If not, you have to redraw that triangle on the inside, given the height, and this is half of that length of the base. Okay, just like if it were a radius here, and then you compute it using Pythagorean. Okay, so you got the ones on the back. Start working on the pyramids, and we'll come back and we'll do the cones in just a minute.